She really wanted to come to class.
We could tell.
Action.
Okay, Renee, this is for you, girl. All right, I want you to get out the handout, the orange handout that says History of the 5E Instructional Model. If you read through that very quickly, what you'll see, particularly on the first page, is it is an old model. The idea started back in 1901 and evolved as it went through different researchers. The current one is from Karplus and Thayer, 1967, and they called it the Learning Cycle, and it was actually developed for special education children. And it turned out it was so successful that they decided, oh, well, this will work for everyone. So in the 1980s, the BSCS, that's the Biological Science Curriculum Study Project in Colorado Springs, put together what they call a 5E. So it went from a 3-part cycle to 5 parts. So I'm not going to read or I'm not going to give you time to read this, but I'd like for you to go through it. And there are several handouts that give lots of explanation about what happens, what does a teacher do, what does a student do in Engage or the Explore or any of the other phases. So you need to make sure that you are very clear about this, because your exam, you will be required to describe this in detail. So you need to, read it, study it, make sure you have a clear understanding of what this 5E instructional model is. And you have different handouts that give you different language describing it. So sometimes that helps if you read it in different languages. If you look at the handout that says in direct instruction, one that has large print on it that says direct instruction, that is a comparison, a shorthand version, if you would, of comparing the direct instructional model to the 5E. You must know all of the phases, so direct instruction has 3 phases, and the 5E has 5. What you need to remember is that the 5E is flexible. I gave you a handout of an article about a 7E. So I don't want you to think that it is inflexible and it's rigid, because it is not. So you're going to need to be able to name these phases, and you're going to need to be able to describe these phases in your exam. This handout also has other descriptions of the 5 phases that you need to make sure you know. And if you would look at the orange handout that is titled Guidelines for 5E Lessons, this is what we started to do during the last class. It says number 1, or step 1, identify concepts and principles. So that's what we did. We identified TEKS that you were going to plan a lesson for. And you always want to think about teaching a TEKS, teaching a learning objective, either some part of a TEKS or all of a TEKS, depending on how broad it is. So you can organize it in a way with the concept map that we explained with that. And then you are supposed to also identify the standards. So it gives you some ideas and URLs for where these different documents are. In step 5, it says to identify the process skills. I never had you teach a process skills lesson, because that would be done with a direct instruction, and I think you probably get more instruction in your other classes on direct instruction than you do inquiry. So remember, you use direct instruction for teaching processes or to teach skills. Now, processes are what scientists use to do science. So your students will be using process skills. So in your lesson plan, you would identify what process skills they're using, and of course there'll be a TEKS, so you'll identify the TEKS number that goes with that process skill. The learning objective, in our case, will be the TEKS. That's what you were assigned. You were assigned a TEKS or part of a TEKS. That is your learning objective. Sometimes you will have districts that will require a learning objective be rewritten. They can have you write it in teacher language, which is what the TEKS are. The TEKS are not meant for children. They're meant for adults, for teachers to use to guide their instruction. So a district might have you rewrite it in a different language, which actually serves a nice purpose because if you have to understand it better if you're wrestling with how do I rewrite this. In other cases, they may have you rewrite the learning objective so the student understands it. And again, that helps you because the more we wrestle with ideas, the better we're going to understand them. So you may see things happen at schools differently from the way we're talking about, and it doesn't matter. I mean, as long as you know the TEKS and you know what you need to do with it, you'll be fine with doing that. The learning objective for your lesson, though, will be the TEKS. You are not going to rewrite it for this lesson. Okay. So your TEKS, the lesson plan calls for you to identify the TEKS, same words that you're going to use for your learning objectives. They're not going to change. The assessment actually should be done before you start designing your lesson. We did not do that this time because we designed it where you just do a 2E first, a kind of a simple thing. But as you're planning this 2E, remember your 3E, you have to add the assessment, the evaluation. So you want to think about, okay, how am I going to assess whether or not students understand this TEKS, this learning objective? Because in the 3E, that's what you're going to have to do, because you're going to repeat your 2E lesson and make it into a 3E lesson. So you get to do it twice to help, which helps you. And then you're going to design the lesson plan. And then there's some other instruction about references, etc., that you can read on your own. And then the last thing that I want you to look at is what is supposed to be your other orange paper, but it ends up being a pink grapefruit, we decided, color, that you just received tonight. This is the rubric that's used to grade your 2E and 5E. Now the way we've designed this is a series of oranges, if you would. So we have, this is orange, this is the 5E. And then you have a handout that's in kind of a goldenrod that is a 3E. And then you have a yellow that's a 2E. So they all belong together. The 2E and the 3E rubrics in the yellow and the goldenrod are merely parts of the 5E. So if you put them all three, it would be this kind of sequence. So all we did was take out everything that didn't need to be in a 2E lesson and put it on the yellow page. And then for the assessment, we had to add that, the evaluation, so that went on the goldenrod page. And then finally, you get the full-blown 5E. Okay? So I want to review with you the full-blown 5E rubric so that you understand, and then we'll go to your 2E so you understand that. All right, so the lesson plan has to be, in this case, the third lesson that you teach, a 5E. The lesson you're planning now is only a 2E, so it has to be a 2E. And you're going to list the unit name and the list of the units, the unit that you're teaching it from. So it might be a TEKS, like cells in biology. That might be a unit, if you would. Yes.
Do we choose our own topic or?
No, it's the one you got. Okay. You were assigned last class. Okay. In the number 2, those are your national standards. So right now, and what you were supposed to have done, I told you last class, was to get into those standards and write out the standard or standards that relate to your TEKS that you were assigned. I gave you a reason for that. Does anybody remember the reason? why should you look at the standards right after you look at the TEKS, before you plan your lesson or do anything else? Pardon?
See how they're different,
Okay, you can see how they're different. What else?
see how they're aligned.
Okay, see how they're aligned. What else?
It'll give you like a different way of defining that.
Exactly, yes, it will give you a different way of looking at, and you're looking to see how similar or different is this TEKS from the standards, and then give you a different way of looking at it, because oftentimes we interpret a TEKS by our own experience, and that's too narrow. So that's why you want to look at the standards to see that. What would be another reason you'd want to look at the standards before you started planning your lesson?
Make sure you understand it.
Well, actually, you can learn more science just by studying the standards, and it will help you develop a deeper understanding of it. The one that I was fishing for is that it helps you understand what the cognitive level that it should be taught in.
You can make sure you're adhering to it,
Pardon?
and you can make sure you're adhering to it.
Right, right. And you may see some differences. For example, the chemistry in the 8th grade is different from the national standards. I'm not going to tell you what it is, because you're supposed to learn that already, so we'll talk about that in a few minutes after we talk about your lesson plan. So, what else are you supposed to learn or put in your lesson plan besides the standards? What else does it say on your rubric?
Learning objective,
Pardon?
learning objective.
No. And number 2, what does it say after the,
Misconceptions.
oh, okay, the LOs are your learning objectives, it's the TEKS. And then the learning objective could be the cognitive objective and the behavioral objective. And then after that, what does it say?
Well, misconceptions.
Okay, after that, it talks about prerequisite concepts, and there should be a comma after that, comma, misconceptions. So prerequisite concepts, Nicole, you have that? Comma, misconceptions. So what is it that they have to know before, or understand before they can understand this particular concept? So you have to know that. And that's why it's important to know what your grade levels below you are teaching. If you're teaching high school biology, you need to know what they're supposed to learn in grades 5 through 8. If you're teaching 8th grade biology or 8th grade science, you need to know what are they teaching in 5th grade. So that means you need to talk to teachers in other schools perhaps. And certainly by reviewing the TEKS with it. The misconceptions are found in your benchmarks for science literacy in chapter 15. You can also Google misconceptions, and as you teach, you will gather misconceptions that you hear from your own students. And then you have to list the college and career readiness standards. So this is what you should have done part of this already in preparation for this lesson. So on 3, we'll look at the lesson and see, has the cognitive objectives or the process skills, whichever it is, been correctly taught? Was the prior knowledge identified in some way, or misconceptions? Or if it's some kind of research design, like descriptive, comparative, or experimental. And then if there are behavioral objectives, where they clearly stated, what is the student supposed to be able to do as a result of this lesson? If you're teaching them how to use a microscope, then that's the objective. If they're to understand the difference between prokaryotic or eukaryotic cells, then that would be what they're able to do at the end of that lesson. Sometimes there's overlap in these things, and I don't mean for you to be redundant, but these are things you need to think about. How will you know a student understands the concept? How will a principal know if they come into your classroom that the students understand? And is it developmentally appropriate? And that goes back to number 2. So if you put those standards in, you're pretty much going to be able to tell whether it's cognitively appropriate. I saw a 7th grade science teacher teaching photosynthesis in 7th grade, which is in the TEKS, but she had them balancing the equations. Well, there were several problems with that. she was a biology major and had gone through an all-cert, so she didn't really understand the TEKS. That's not in the TEKS. In fact, they don't even balance equations until high school chemistry. In the 8th grade, it's only recognized if the equation is balanced, not balancing it. So, that's why all of these things are very important for you to do, because the students didn't need to be balanced in the equation. It certainly didn't help them necessarily understand it because they didn't have the math skills to do it. They don't get those math skills till 8th grade. So it was a waste of the student's time, her time for planning the lesson, and it denied the students the abilities to, or opportunities to learn what they actually needed to know for the 7th grade. ELPs. There are 4 ELPs. Remember we talked about 4 ELPs, and I added a West ELP, which was what?
Doing?
Do science. So in other words, they need to be doing something in your lesson. So you need to identify, when will the students see science? What are they going to see? Are they going to see some manipulatives? Are they, et cetera? When are they going to write science? So during the lesson, they should be taking notes or drawing or something, writing science. They should be reading science sometime in the lesson. Might be just instructions for the lab activity. That's okay. And then they should be hearing about science. So it might be when they're talking to their shoulder partner. It might be when they're having a class discussion. So you're going to identify in your lesson plan, when are students going to do these ELPs? That doesn't sound exactly right, but you understand what I'm saying? Use the ELPs, and then when are they going to do the science, to learn the concepts as well as academic vocabulary. So there's an example there. Students will speak about concepts during the engage phase and small group discussion. When you get to a team, when you teach this as a team, number 5 will be important. But notice that you must dress professionally. You must be ready with your lesson on time, PowerPoint loaded, all materials ready prior to class. You do not have time to come in here and set up things. If you want to set them up, 2 days before, we have plenty of room to store. Nobody uses this room except us, so that's not a problem. Or just set it up partially. It doesn't matter. We can have trays and stuff where you could just set your materials up. Dress professionally means that your body is covered, the appropriate parts are covered, I guess that should be said. No shorts, jeans, tight clothes, sandals, or tennis shoes. You're to dress professionally as you teach. If there's any kind of safety issues, you need to plan for that. Generally, these lessons don't, we're not using hazardous chemicals or anything, but if they're using vinegar, you need goggles for it. So you need to tell Nicole ahead of time, or Utian ahead of time, and they can have the goggles available for you, or gloves. Okay, the lesson plan. And this is what we talked about last class. The lesson plan has to be set up so that each activity, example, graphic, video portion, etc., teach the learning objective. Everything you do in that lesson must teach that learning objective. So is the lesson concrete? Is it known? Is it, one concept per lesson, known to the unknown, or concrete to abstract? You're always focusing on those fundamental principles. This is a football, remember? Include anything that anyone would need to replicate the lesson. So if you handed this lesson plan to someone, they would be able to replicate it exactly because that's how well you've written it. You're going to have a complete list of equipment and materials, and it would be per teacher. So it might be the teacher has the laser pointer, or the clicker, as some students call it, and the PowerPoint file, etc. But the student, each student needs one copy of this handout. Each team of students needs a basket that will have marbles and paper clips and whatever in there. but exactly how many. We'll have 2 marbles and 3 paper clips per basket for every 2 students. So very specific about what kind of materials that are gonna be used in the lesson. You need to have a method for assigning the cooperative learning roles. We have these hints for you to use. So you can have students in groups of 2 or groups of 4. We have a bunch of these somewhere on the cards. So we've got about 6 or 8 different ones, so we have plenty for you to use. We have baskets for you to put in your materials for doing your activities. And you need a method for assigning. It doesn't say get with a partner. It says you 2 will be a team and you 2 will be a team, or, you know, tables, students 1 and 2 will be a team and students 3 and 4. Doesn't matter, whatever you decide, but some method, and you don't come in and you don't give students choices. I think I mentioned this before, that when I was teaching, I used to have the roles on there, and our students were numbered in groups of 4. They knew what their number was, and so each day when I would have some activity where I used cooperative learning, I would put in the numbers, and so student number 1 knew that they were the PI for that activity that day, and you rotate your cooperative learning roles. If you can put them in groups of 2, that's better than 4, and never more than 4 in science. And if you put them in groups of 2, then you're going to combine 2 jobs. So student 1 is going to be the PI and the reporter, and student 2 is going to be the materials manager and the maintenance director.
What is the acronym for?
Primary investigator, not private investigator. That's not scientific. It's primary investigator.
In the general science, we use that method, but instead of doing numbers, they all have a different suit, and you just switch out the suits. So somebody's always the club, and we just change which role the club is on.
And it doesn't matter. I mean, if I were you, I wouldn't waste time trying to come up with some clever way. Just do something simple that you need to spend your time designing your lesson. But you must use cooperative learning. Okay, on your lesson plan, you need a footer with the concept, so yours would be TEKS 4B or something like that. And maybe a shorthand of what that is. A page number, your last name, and the semester. So in the 5E, we look at natural selection, so that footer might say NAT, SEL 4, Spring 13. And you don't need them on the PowerPoint if you want to correct this. And any new academic vocabulary needs to be consistent with the national standards and the TEKS. So your lesson will have new academic vocabulary, hopefully not a bunch. And then somewhere on here we have word wall. I'm not sure where, Nicole. But the word wall is reserved for important academic vocabulary. Not every science word that you use in a lesson is important. But the important academic vocabulary you're going to put on a word wall. We showed you the 2 that we have over there for you to use the Venn diagram. Okay. You need to tell students why the concept is important. They need to know why it's important. And it's not important because it's on the test. It's not important because you you need it for the next grade level. Find some real reason that they need to learn this. If you need to, ask some other, other students that age, other children that are that age, and find out why it's important to know that. Your body language tells a lot about how much you like science. So you're not gonna just get up there and stand very still. You're gonna move around, you're gonna use hand gestures, you're gonna have inflection in your voice, and you're gonna show that you really like science. Because if you don't like it, your students are not gonna like it. We did, years ago, one of my high school students for science fair did a survey in the 5 high schools in Northeast School District. And the number one reason that the high school students said they didn't like science, yes, lack of enthusiasm by the teacher. Not that it's hard, not that it's, a lot of work or, not any of that you might think. Lack of enthusiasm by the teacher. And in fact, you want to tell your story about the teacher you observed and what she said?
My cooperative teacher is not horrid, but
I was just telling what she said.
she was in school, she was in school for physical therapy, and she got burnt out, and so she has taken her alternative certification, and it shows that she doesn't love science.
What did she tell the students?
That they can't do the hands-on experiment.
Okay, so she doesn't let the students touch the lab materials. She only does a demo of something, and she has them watch it. She won't let them touch it. I suspect because she doesn't know how to manage students using materials. And that's an extra thing that science teachers have to learn, because we have to use materials. Another problem was that it was a box and she was moving around sand, and so she's doing it up here, I assume on the demo desk, and saying, see?
No, it's like one of those plastic shoe boxes, and it has colored sand inside of it, and on both ends it has a paddle that pushes the sand in or lets it move out, and there's handles on the outside of the box.
But it's at a level the students can't see.
So she's standing up, and all the students are sitting down, and she's standing up at the front of the class, going, see how when I push it together, it creates like 2 plates coming together, explaining tectonic plate movement. So it's coming together, see how it comes together, and then when I pull it apart, it creates a rift, see? Okay, great.
And then what else did she tell the students about being in her classroom? You said that she told them that she knew that they didn't like her classroom.
Oh, no, the kids told me that.
The kids told
The
you
kids
that
have told me that they don't like her class because it's boring,
because they don't like her class because it's boring.
because it's boring and all they do is take notes.
Okay,
Worksheets.
is it? Did you see that, Renee? Worksheets. The idea though is that you have to show your enthusiasm. Sometimes you have a personality that's kind of quiet, and it's not normal for you to be, all Miss Frizzle or whatever, and that's okay. I mean, you will show that you like science in your own way, but you have to develop that. And sometimes it's just, you guys are gonna love the class today. Sometimes you just tell them it's gonna be good, and they're gonna think it's good because you told them it's gonna be good, and you act like it's going to be good. So it's a lot of teaching is acting. So you're going to, as I said, show enthusiasm in some way, whether it's smiling or hand gestures or whatever.
But, my cooperative teacher is very enthusiastic, she says all the time, this is gonna be fun, isn't this exciting, or whatever, but it doesn't translate to the students because the work that they're doing
It's
isn't
not.
fun. It's all worksheets, and she doesn't answer questions very well, or at all sometimes, and cause she's so busy being bubbly and enthusiastic, she doesn't pay any attention
Right.
to them.
Remember the 3-legged stool I showed you?
Yeah, it's one of the students, in the pre-AP class, the kids always ask him the questions, because he, knows and, he hears them whenever they're trying to ask the question. Or they'll ask me, but they're like, see, he's better than her,
explain answers.
But
I mean, if a student doesn't understand something, you don't just repeat it louder.
No, that's what she
No.
does, yeah.
Yes.
Like, she's like, oh, I'm not gonna answer that, you're gonna figure it out by yourself. I'm like, they don't understand the question, like.
Well, the question certainly has to be clear, and there is some value in having students figure it out. That's what inquiry is about.
Oh, yeah.
So, you know, there's that kind of balance in there, and it's not, I think that the language that you use about, well, you're gonna have to figure it out, is not inducive to having students understand that they learn more if they figure it out on their own. And to encourage them that you will, you're gonna have to work at this, and that's what you need to do to prepare students for the adult world. You've gotta figure life out. You're not gonna have somebody sitting there telling you the answers. You have to figure it out. And so that's what we have to do with our students, but I think we have to train them and tell them that this, you know, you're gonna learn how to think better in this class. You're gonna be given some assignments that are gonna be rather difficult. I'll try to guide you through them, but you're gonna have to work at this. I'm gonna work at it, and I expect you to work at it too. And, you know, you start out with things that are easily doable initially, to kind of move them into that area to where they're working harder, they're thinking harder, and having students explain answers to each other as well as to the whole class is very beneficial. It helps teachers understand what's going on in their brains too. Okay, enthusiasm, we did that. We're not gonna do the engagement, we'll talk about that later. You are going to get into the exploration. It has to be appropriate to teach the concept, and it has to be interesting. You need to practice it so you know how many minutes it will take. And with an exploration, you're not gonna know how many minutes it's gonna take if you don't hand the instructions to somebody without saying anything to them and have them read it and do it, and you just watch, and you can see where there are holes. They don't know what to do next because the instructions aren't complete, or it doesn't turn out like you think it should because the instructions were not correct or adequate, or, you know, lacking in something. So you gotta practice your part, but you also have to practice the activity. You have to pilot the activity yourself so you know exactly how it should go, and then you're gonna look at your instructions, your procedures, and hand them to somebody, and if they should be able to follow them exactly the way it should be done. And all of those will be on your PowerPoint. Your whole lesson's gonna be on the PowerPoint. PowerPoint's not for lecture. It's to guide you with procedures like we did early on with the observation, inference, etc. Okay, make sure your sequence is correct. Put them in bulleted steps. It's hard to read a paragraph when you're trying to follow procedures, so pull them in bullets. On your PowerPoint, your bullets are not complete sentences. They're phrases with key ideas in them, and you're not going to have more than about 4 or 5 on a slide. How many of you know what an operational definition is? Okay, you want to tell us?
Can something defined, in your own, or something explained in your own words, by, like, according to what the object of the thing, you know, does, or.
How do you know what to say?
Because you know what it does.
Because,
Because you've experienced it.
exactly. So you can write the operational definition of the concept because you experience the understanding of that concept. Remember the peanut butter sandwich idea that we talked about for procedures, or the balance, the activity about balancing that I was telling you about in that physics training, that I knew that they didn't get it right because I knew the formula, I knew the equation, but they wrote their operational definition, and if the instructor came over and followed their operational definition, he said if your operational definition is correct, then it will balance if no matter where I move the mass or whatever. Of course, it didn't because they had it wrong. They had not worked it out so that it was correct. So you are having students write and be able to explain their operational definition of the concept based on what they learn in the exploration. Okay? And that's important for students to do that, to write it in their own words, and to talk about it in their own words. Because when you get to the explanation, that's when you kind of deepen and broaden their understanding of it and add that academic vocabulary. The misconception should be challenged in the exploration. If, let me see if I can take a good example. In batteries and bulbs, if they think that a bulb can't be lit with one wire or something, and they discover that it can be, then you're challenging that misconception that they had in the inquiry, in the exploration. So that's why you want to know what the misconceptions are, so you can choose or design an exploration that will challenge those misconceptions. And remember, misconceptions are hard to change. They're not going to change because you tell them that's not true. What is a term that we use to get students to change their thinking about something, about a misconception? What do we have to do to students? Well, you may reteach that the exploration is to challenge that misconception. And the only way you can challenge a misconception is what we call putting students in a cognitive imbalance. Oh, wait a minute, that's not exactly like I thought it was. Let me do this again. So telling them that it's wrong is never going to change their minds. They're going to keep that misconception. They may write it correctly on a test, but you have to change their thinking. So they have to experience it, and the only way they can experience it is with putting them in a situation that puts them into that cognitive imbalance. Then they're open to new learning. You will have an exploration guide, so that will be a piece of paper that says exploration guide on it, and where students are writing or drawing during the exploration. Every part of a lesson should have questioning in it that we call check for understanding. Cooperative learning, we've said that already. Materials, mat. Have y'all looked at the materials mat online yet on Tracks? A materials mat would be something like having a piece of paper, and on the piece of paper, you would have a circle for a beaker and something like this, or whatever that is, a spatula or something, and then, this has something else, and this one has something else. So, in other words, this would be a materials mat, and every piece of equipment goes on that mat. So that at the end of the class, when they clean up and everything, all the materials are there, and you just have to walk by, and it's easy to see that everything's cleaned up and ready to go. Except the last period of the day, when you're not only going to check to see if it's clean and ready to go, you're going to have a method to get all the materials back into a way that they're stored and ready to go for whenever the next time is that you're going to use them.
Could you repeat, we need a piece of paper titled, what it was just before that, for?
No, it's not titled anything. It's a materials map. It might be titled the name of your lesson or something.
Exploration guide, thank you.
No, that's not what I was talking about for the exploration guide. The exploration guide is what they're going to write on.
Yes. I couldn't remember what you said.
Yeah.
Thank you.
Exploration. Anybody have questions about their exploration?
So do we need to bring that materials and that with us or something like that whenever we do our lesson?
Yes, it's part of your lesson.
Okay.
Okay. Remember we talked about how science teachers have a more difficult time because they've got all these materials they have to deal with. So part of what I want you to do in this semester is that you will, learn a little bit about how to deal with us.
And for your materials, any copies you need made of anything, you need to talk to me before the day of the lesson so that we can get those run off. Or just before the lesson. So your lesson's on Monday, you could come in on Monday morning because I'll be here.
So should it just be like,
Or email.
Or you can email them to me and I can get them copied, yeah.
Or you UT and he can do it too.
should it just be like the material